Hi, everyone. Let's start with the first unit of introduction. This is, let's say, a review of what you studied last semester during the class of the subject of design and evaluation of user interfaces, where we studied a topic on accessibility. So you may know many or most of the things that we are going to review now, but it's important that you check that you know them all, that you're familiar with them, because these are the foundations of what we will do after during the course. So first of all, let me start with the human perception issues in general. I wrote here, which means that these are not the issues of people with different disabilities, but these are issues that we all share, that we all have as humans. And they relate to perception. I included the visual channel, the motor, well, it's not a channel, but it has something to do with the use of devices in this case. We need to touch some things in order to do stuff. And then we have the hearing channel. And I also added some cognitive issues because they are related with the use of the rest of them. So for the visual issues, we need for contrast. Every time that we're going to read something or to visualize something, we need enough contrast between text and background so that we can clearly distinguish, for example, text, and then we can easily read it. So we need we need contrast, enough contrast. And then naturally we will seek for some structure in everything that we see. For example, we detect as a group things that are together, like close together. We think of them as a group, or we visualize them as a group. Also, our peripheral vision is poor. What do I mean by this? I mean, even if you have a normal sight, you will notice that the things that you're focusing your view on, they are clear. They're very clear, but the rest of the things that you see around you is there, and you can like perceive them, but they're not really clear. They look sort of blurred. So that is our peripheral vision. And this is an important issue to consider when we are designing interfaces, because I don't know if it has happened to you that sometimes you fill in a form and then you press the send button and nothing seems to be happening. And you press it again thinking that maybe you missed it the first time, but in fact, something is happening, you just cannot detect it. Sometimes there is an error message up there. But since that message is not in your field of vision at that very moment, you cannot perceive it so easily. So this is the reason for that is that we have poor peripheral vision. Another issue is that we have a limited perception and difference of color shades, and it's related to contrast. For example, we can distinguish very easily the black from the yellow, but maybe we will not, it won't be so easy for us to distinguish light yellow with slightly less light yellow, okay? So this is something to consider because first of all, we need to have enough contrast. And second of all, it's important because sometimes designers tend to forget this and they sacrifice the visualization, for example, of some graphics with too many parts. They sacrifice visibility with beauty. Let's say instead, if they have a specific color palette for their site, they want to use the same colors for the graphics, but sometimes the graphics, they have too many divisions, too many parts, and they need to use different contrasting colors. So let's not forget that we have a limited perception in differences of color shades. For hearing, I could only mention here that we have short retention, and this is actually related to memory, but the perception comes through hearing. So when we hear something like, let's say when someone introduces themselves to you, himself or herself to you. They tell you, hello, my name is Silvia, for example. And then seconds later, you forgot, like you completely forgot what their name was. And this is not something that just happens to you. It happens to everyone. This is a memory limitation, and it's related to the fact that when we hear something, we will forget it like a couple of seconds ago. It's different from when we see it, because when we see it, it's there all the time. We don't have to remember anything. But when we hear it, most probably we will forget it a couple of seconds later if we haven't stored it in memory. So that's for hearing. And then for motor issues, we know that the perception is touch, right? But I consider here the motor issues because of the movement. We need to move in order to reach for targets in devices or in computers. So what do we need to consider here? Okay, the most important thing to remember here is that the difficulty of reaching a target will depend on the size of the target and on the distance to that target. That is the reason why it's easier to tap on bigger buttons than smaller ones. And it's easier to reach things that are on your finger. For example, when you're using a smartphone, it's easier to reach things that are in an approximate distance from your thumb than those who are on top, for example. So remember that difficulty depends on the size and the distance to the target. And this is very important to consider, especially if you're designing for small devices. The smallest, the most important this law becomes, which is, we know it as Fitts law. So I think that's the most important thing to remember about motor issues. And lastly, for cognitive issues, we should remember that we have a limited short-term memory. This thing that I told you about forgetting the names of the people who introduced themselves to you the first time, it's a short-term memory issue, and it's completely normal. We're limited. It's a limited buffer, and it's a temporary buffer. So if we want to store things in our long-term memory, which means to memorize things, normally it will take time and practice. So those are let's say, two issues or limitations that we need to take into account regarding the cognitive aspect. So again, this is just for people in general. This is not, we're not there yet with people with disabilities. This is for everyone. But actually, people with different disabilities are not different from this. Like, we are all part of the same human breed, the same breed. So they are not a different breed. They just have one or more of these perception channels unavailable or blocked, or they have difficulties perceiving through one or more of these channels. But other than that, they're exactly the same as us. So these issues that we're reviewing now, they apply to everyone. Now, with people with disabilities, they might need some assistance perceiving through these different channels. So let's have a look at what they need. This is specific for people with disability, and we will start with the visual impairment. It can be partial or total. Total is easy because it means they are completely blind, someone is completely blind, and they are not able to detect anything visible anyway. But also the impairment can be partial, which means that they can see something, but they have low vision because the vision can be distorted, or maybe they cannot perceive things in the same way as people without disability. Like in this example, there are the two semaphores, the traffic lights. There is a comparison between how a people with normal sight sees the semaphores and how people with color blindness see them. And I mean, it's evident the difficulty is not the same distinguishing green from red than not distinguishing them, especially when you're driving. So the enabling technologies, the technologies that assist them in the use of computers and smartphones and other type of devices of this kind are this. And the main one is the screen reader. The screen reader, as you may know, reads aloud the contents of the textual contents that are active on a screen. Okay, so it's the main technology. It's like the basic one. It's in I think every operating system, and it's there for people with blindness to use it. It enables them to hear things. They cannot see them, but they can hear them. But nowadays, screen readers can only read text. Okay, that is now. Right now, they can read text. So it's something just to take into account when we make graphical interfaces. I mean, with too many graphics. There are also the Braille displays and the Braille input in smartphones, which are for people who know Braille, who can read and write it. So Braille displays is like the same thing that you hear through the screen reader is written in one line of Braille, so that you can, read it with your hands. And also you can input through these devices. Some of these devices, the Braille displays, are also keyboards. For those which have keyboards, like the one in the picture, people can can type in Braille so that you can get the actual letter in the computer. But these kind of displays, the Braille displays, can also be used as standalone devices without, like, separated from the computer, because they are like a small computer on their own. And also some devices, most devices have the option to input with Braille characters. With the combinations of six dots, you can make the different characters. So you can type in Braille on your mobile device. And lastly, we have the magnifier. The magnifier is the zoom. So this is only useful for people with low vision, just to make things bigger. That's the principle. And then we have people with hand motor impairment. And I'm focusing on the hand motor impairment because it's the hands that we use in order to interact with computers and mobile devices and other type of devices. So for hand motor impairment, this type of impairment can come in can have different manifestations. For example, a person can have weakness in the muscle, usually caused by some disease. So they have hands, they can use them, they're just weak. They don't have enough strength to press buttons, physical buttons, or even to, for example, to hold a mobile device. They could also have shaking hands or stiff hands, resulting, for example, from arthritis. So that kind of condition also makes it difficult for them to use these kind of devices that we're talking about. They could also have some deformity in their hands, also caused by disease, and they can move their hands maybe, but they cannot move them. They cannot have the same freedom of movement because of the shape of their fingers. Or they could just, not have a hand or both hands. That is the lack of limbs. So the enabling technologies for them, I mean, of course, it depends on the type of hand motor disability that they have. They are adapted keyboards, like the one in the first picture. Actually, this is not an official keyboard, it's more like a prototype, but it's an example of an adapted keyboard. The kid cannot use his fingers. You can see that he makes fists. So that is the way that he can interact with the computer, just by pushing buttons. So that is an adapted keyboard for his specific condition. There are also keyboard switches, which are also adapted keyboards, but like the one at the bottom, the one with the two red buttons and another small thingy. Those are also keyboards, like they are input devices, but also for people, they're also focused on people who cannot use their fingers to type. They have reduced input, but they still can do some things with it, some input. And lastly, we have the voice assistants. The voice assistant is probably the most efficient way for a person with hand motor impairment to input information, especially on small devices. I mean, it's easier for everyone, but in particular for people with this kind of disability. Let's take the example of the person in the middle. She's using her iPhone with Siri, and she's giving instructions. As you can see, her hands are like, she's not using her hands because her hands are have some deformity that makes it really difficult for her to use the device. So for her, it's a lot simpler to use the voice assistant. But of course, voice assistants are not able to do everything, but they facilitate interaction a lot for people with hand motor impairment. And then we have the hearing impairment. I think I consider that the hearing impairment one of the most difficult to deal with. I think it's this kind of impairment really isolates people with it from people without disability, because they cannot hear us, and they cannot sometimes they cannot speak from not being able to hear. So let's say with people with blindness, you can still talk, you can communicate with them, you can have a conversation. With people with motor impairment, is the same. You can have a conversation with any of them or between them, etc. But for someone who is deaf, unless you know sign language, it's going to be very difficult to communicate with them. So that causes social isolation of people with this disability, I mean, from the rest of society, because between them, of course, they can communicate without any problem, as long as they speak the same sign language, because sign languages are not universal. I mean, there is not a universal sign language, but sign languages vary from country to country, and sometimes even from region to region. So, of course, I'm talking about complete deafness, people who cannot hear anything, but the impairment can also be just difficulty in hearing, but they can still hear something, just not to the degree of normal hearing. So for people who can hear partially, the enabling technologies are usually the cochlear implants, which is like a small device that helps them like enhance their capacity to hear. But that's only for those who can hear a little bit or something. For those who are completely blind, completely deaf, the usual way to go, the usual solution is offering captions or subtitles, which means that they can read the contents that they cannot hear. On the other side, you will find out a little bit later, hopefully with the activity that you will make, that written text is not the most appropriate way to communicate contents to deaf people, and you will find out what kind of difficulties they have reading textual contents. But that's a little bit later. For the moment, captions are the most common solution that is offered for people with with deafness. I added here a video from Mafer Lopez. She says that he's going to teach you Lengua de Señas Mexicana in less than 10 minutes. Actually, you will not learn Lengua de Señas Mexicanas in less than 10 minutes, but you will understand, you will see what sign language is like, and you will learn the alphabet of signing in Lengua de Señas Mexicana. You can learn how to spell your name, but you will also understand why it's so, they don't communicate using the alphabet with signs, but they have their sign language to represent expressions or even complete sentences. So have a look at the video, it's really cool. And you can learn how to sign hello, how are you, and then your name and stuff, basic things. So in order to know more, if you, for example, if you're wondering how, if blind people dream, I think they have one of the answers to that question, or I don't know, things that you may wonder about people with deafness or blindness. I'm leaving you these two videos so that you can have a look. The first one is Deaf People Answer Commonly Google Questions About Being Deaf. You're going to be surprised. I was surprised looking at the questions that people make, and they answer them. And then we have the second video, which says blind people tell us which questions annoy them the most. So they get a lot of questions apparently, and for blind people, this video is about the questions that annoy them the most, like how you go to the toilet and stuff. So have a look to those videos in order to know more. And during the class, we will discuss some of these topics and questions that you may have about it. And I will let you know the activity for this first unit, but we will talk about it during the class. Please make sure that you understand these things. The video is short, the slides, I think they're 5, they're not many, but they have very important information, which are the foundations for the rest of the things that we're going to do during the course. So have a look at it and see you next class, okay? Ciao.